Hi friends, hope you're all doing well. In this video, I'd like to talk about relationships in Tableau. Now my attempt here is to make a comprehensive video that will be like a one-stop shop for all your doubts or for all your queries related to the concept of relationships in general and then relationships in Tableau, of course. That would be the final target. So I request you all not to skip the video. I would request you all to watch it till the end, and I promise you it will be worth every second that you invest here. It might be a slightly lengthy video because I'm trying to make it as comprehensive as possible. Let's see how it goes. So in order to understand the concept of relationships, we need to understand how data is stored in tables. We need to understand something called as data redundancy, which is a problem. And we need to understand how we overcome that problem through data normalization. Then we will talk about types of relationships, and ultimately we will see how this is implemented in Tableau. So let's try to understand data redundancy first. Now I have a very simple employee table here. These are the people who are working in an organization across different departments. And we can see that the name of the manager and the department's email are getting repetitively stored. This is data redundancy. And when we store the data, see, no database architect or engineer or database administrator will design their database in such a way that they put the entire data into one single big table. Because when they do that, it leads to redundancy. It leads to data being unnecessarily stored repetitively, like in this case. And it also leads to a lot of anomalies in the data, like insertion anomaly, deletion anomaly, update anomaly. What are these anomalies? So what if the data is being repetitively stored? How does it matter? Right? I'm sure you have these questions. So let's say there's a new employee who joins the organization, employee number 6, and the employee's name is F. Let's say this person is taken into the IT department. This is all I need to know. But what happens is, because this table has the name of the manager and department also, the name of the manager and the department will also have to be inserted. Every time a new employee joins the organization, the name of the manager and the department are also being inserted unnecessarily when we could have stored it in a separate table. This is insertion anomaly. Repetitively, the data is getting inserted, leading to redundancy, insertion anomaly. Now, let's say Ravi left the organization. He's no longer the manager, and some new person joined. Let's say Mohan took over as the manager of IT department. Now, what happens if the person leaves, another person joins? Everywhere the name of the manager is to be updated. So everywhere I have to replace Ravi with Mohan. So this is leading to updation anomaly. Updation anomaly, because we have stored it so many times repetitively, every place it will have to be updated. Then what is deletion anomaly? Let's say employees start leaving. This person leaves. This person leaves. And if this person also leaves, D, who's working in the HR department, I'm not just losing the information for the employee. I have no longer access to HR department's data. I no longer have access to the name of the manager or the department email, because it is not being stored elsewhere. It is being stored in this table. If let's say this person quit and this person quit and this person also quit, when the last person leaves, when the table gets empty, we notice that we're not just losing the data about the employees, we're losing the information about the managers, the department email, maybe the department's phone number, everything is gone. So this is deletion anomaly. Maybe it's not like the whole organization has broken down, only the employees left. Organization is still there. Maybe the managers are still there. Maybe they're recruiting new people. But we have lost the information about the managers once we lose the last record in the table, once we delete the last record in the table. Everything is gone. So this is deletion anomaly. So to avoid such anomalies, what people do, what database architects and designers and engineers do is, they try to store the data into separate tables. Now, one very important point to remember here is, the goal of data normalization is not to avoid redundancy completely. It is to minimize redundancy. It's not possible to totally avoid it, but it can be minimized. And that is where a lot of normal forms come into picture. Of course, we'll not get into what are normal forms, but we will try to understand how to, in a slightly better way, store this data. Rather than keeping it in one table, if I could split it into multiple tables, let's say employee name in one table and department details in another. So I'll include HR also. Priya is the manager, HR underscore department at gmail.com is the name, is the email address, supposing. Okay. Now, when a new employee joins the company, say employee 6, let's say this person went into the HR department. Okay, let's say employee 7 into the IT department. So I'm not unnecessarily storing the name of the manager and the department's email over here in this table. All I have is the employee ID name and the department to which the person belongs. Of course, this is repetitive. We can't avoid this. Then the department details have been taken into a separate table where we again have the department ID, the name of the manager and the department's email. So when I insert a record, I'm just inserting the bare minimum information necessary. I'm not unnecessarily inserting extra details. However, if I am given the name of the employee, I can definitely look up the name of the employee here, figure out the department to which the person belongs. Then I can reference this table. I can take this department and cross-check in this table and figure out who's the manager and what's the department's email. So there is supposed to be a relationship between these two tables. Using the data from one table, when we try to reference another table and fetch the corresponding data, it is called a relationship. A relationship needs to be established between them. Okay. Now, update anomaly is gone. Insert anomaly we can see is gone. Updation anomaly, if the name of the manager changes, like some other person has come in as the manager, I need to change it in only one place. I just need to change Ravi to Mohan here. Job done. So only in one place I'm updating rather than updating every record like in the previous case. And what about deletion anomaly? Even if all of the employees quit, I still know what are the departments present here. I still know who are their managers. I still know what is the department's email. So I'm not losing data here. Deletion anomaly is also taken care of. So that is why we need to store the data in a normalized form. So what is data redundancy? What kind of problems arise because of it? And how do we overcome it by storing the data across multiple tables? I hope is clear. Now, this concept of storing the data across multiple tables is normalization. Then we were talking about, given the name of the department here, how can we fetch the details from here? There has to be a relationship defined between them. So there are multiple ways of defining the relationship. We have one-to-one relationship, one-to-many, many-to-one, and many-to-many. When to go for which relationship? So let's say there is one table which is having the names of citizens of a country. Okay, let's say names of certain people living in a country are here. And let's say there's another table with their Aadhaar ID. Aadhaar is the unique identification number given to every citizen in India. So if it is the US, then maybe you can say social security number. And where I live in Bahrain, we call it as CPR number. A unique number. Every country has a way of uniquely recognizing its citizens. Okay, so let's say here I have the name of the citizens and here I have the unique identification number of the citizen. Now, given the name of a person, using this name, when I search this table for the Aadhaar number or social security number, I will get only one. Isn't it? One person will have only one Aadhaar ID. Or given the Aadhaar ID, suppose someone gives me the Aadhaar number, and if I have to cross-check here and figure out the name of the person, I'll get only one answer. Isn't it? One Aadhaar is linked with only one person. One person has only one Aadhaar. So there is a one-to-one relationship between these two tables. When I search, given this data, when I search here, I will get only one output. Or given this data, when I search this side, I'll get only one output, one-to-one relationship. Now, let's say we have a table which contains the names of doctors in a hospital. And here we have the patient list. So one doctor could be treating multiple patients. Each doctor could be treating multiple patients. So this is one-to-many relationship. Okay. And a patient, let's say, of course, these days a patient could be seeing multiple doctors. Let's just assume that this patient is seeing only one doctor, maybe the family doctor, and for every need they go to that person. So given the name of the doctor, I can fetch the names of the patients that the person is treating. But what will happen? Given the name of the doctor, I will get multiple patients data. There could be many patients that he or she is treating. Or let's take another example. Let's say you're shopping. Let's take a retail database like Amazon. Okay, let's say you have an account on Amazon, customer number 1, customer number 2, customer 3, customer 4. And let's say this is the transaction table. This is the transaction table. Every time customers place an order, entry is made into this table pertaining to that transaction. Now, customer 1 could have placed multiple orders with Amazon on multiple occasions, purchased multiple items. So one person could have made multiple transactions. So given the name, suppose I search for Bhargavi in Amazon's database, she might have purchased 3 or 4 times or n number of times she might have purchased. So all the orders placed by her can be retrieved. Given the name, I can retrieve a complete list of orders placed by the person because there is a one-to-many relationship. One person placing multiple orders. But given an order ID, which is placed by a person, will it return multiple persons? So if someone gives you, this is the order placed, track the customer who placed that order. I'll give you the order ID, track the customer who placed that order. So what will we do? We'll take the order ID and search who is the person who placed it. And we will be able to get the name of that person, that one particular person who placed the order. It's not possible that an order is placed by multiple people. A person could place multiple orders, but an order is placed by only one person. So if I'm searching from here to here, I will get only one output. But if I'm searching from here to here in this direction, I'll get many outputs. So this is one-to-many relationship. One customer associated with multiple orders, one-to-many relationship. But each order here, if I have orders table, if I have the list of orders, and if I have customer table here, so given the order ID, when I'm looking for the customer, I will get only one unique output. Given the customer, if I'm searching for the orders, I'll get many outputs. So it just depends on which table is on which side of the relationship. This will become many-to-one relationship. This is one-to-many relationship. This becomes many-to-one relationship. So it's just which side you put the table. Okay, and then many-to-many, we can think of many examples like doctor and patient for that matter. One doctor treating multiple patients, a patient visiting multiple doctors. For each ailment, they go to a different doctor. So whether given the name of the doctor, I can retrieve the complete list of patients the person is tending to. Given the name of the patient, I can get the complete list of doctors that patient is seeing. So I think it is more relevant in many-to-many scenario, doctor-patient scenario. I hope you all understood. So what is the one side of the relationship and what is the many side of the relationship is what you need to figure out. Then you can go ahead and define the relationships. Okay, this is the concept. Now let's see its practical implementation. Now I will show you a data source that we use a lot in in Tableau, which is let's say coffee chain. So when you Google for coffee chain also, you will find it in different formats, Excel format, Access format, etc. When you're trying to create relationships, when you're trying to denormalize the data, sorry, not denormalize, when you're trying to normalize the data, first you have to identify what will become the fact table and what will become the dimension table. We follow something called as a fact dimension model. So fact table is that table which is the transactional table, which holds the transaction details on a daily basis. Take this business called coffee chain, where they are selling different types of coffee and tea related items. Every day they sell. So every day new transactions happen, and every day new records are inserted into this database, where we have the information about how much profit the business made, what is the total sales, what was the targets set up, what are total expenses, what is the marketing expenditure, what is margin, so on and so forth. So for every transaction, all these details will differ. The profit from each transaction could be different. The selling price in each transaction could be different. The marketing costs for each transaction could be different. So this is transactional data, which has to be kept in a separate table. Now, if you look at this table, there is some data that is getting unnecessarily repeated. This is absolutely denormalized. Whole thing is sitting in one single sheet here. So the customer comes and they place an order to purchase an item, a product. Let's say somebody purchased decaf Irish cream. All I need to know is what is the product, but information about the product line, about the product type, and whether it is decaf or regular. This is getting unnecessarily repeated for every product. Redundancy is there. Okay, so let's say in a particular area code, customer placed an order from area code 970. So again, 970, another person from that area code placed an order. Now, what is the state under which that area code would belong? The territory and the territory size, whether it's a major territory or a small territory, whether it is central, east, south, west. This is again getting stored repetitively and unnecessarily it is getting repeated. So we have the entire data stuffed into one table, which is leading to a lot of data redundancy. Now, how do we solve this problem? As a DBA, what is the person's responsibility to bring this data into a more structured format, to normalize this data? So if I am given this data, how would I approach it? If you are given this data, how would you separate out the static part of this data from the transactional data? How would you separate out the static part? Something that doesn't change is static. So if decaf Irish cream is there, it is always made from beans. The other option is leaves, whether it is leaves or beans. Okay, it is definitely a coffee all the time. And it is definitely decaf. So this is not going to change on a daily basis. This is not going to change. So data that is static, which does not change, need not be repetitively stored. So what I could keep here is just the name of the product that is being purchased. And the product line, the product type and type, I could take it into another table. Okay, similarly, area code I need to know. But an area code would always belong to a particular state, a particular territory, which will belong to a particular territory size. Every time I don't have to go and save this information. So this is the static information which will not change frequently. So that part of the information which does not change frequently, which is constant, which is static, has to be removed. So I will take this data, and the ideal way of storing it would be to break it down into multiple tables. So like this. Sorry. So I'm going to keep the factual data, which is mandatory over here. Okay, factual data, which is mandatory, which changes for every transaction, what kind of profit, what is the sales, what is the marketing cost, all this. And product ID. I've given an ID to every product. Product 1, product 2, product 3, so on. Area code. Then I have created a separate table for product where I have details about the product. You see now, just the product ID, given the product ID. So if somebody gives me the product ID that, okay, product 1 was sold, what is the name of that product? I can reference here and figure out whether it is of type coffee or tea or espresso, whether it is regular or decaf, whether it is beans, or maybe another column I can add here, whether it is beans or leaves. So I took out the static part, which doesn't change frequently, into a separate table, thereby avoiding data redundancy. This is normalization. This becomes the dimension table. We call this dimension table. Similarly, for location, given the area code, the state, the territory, okay, and the territory size are separated out. That's it. I have a small table with the list of area codes, the market, or basically the territory and the region. Now, this is normalized data. Now tell me, try to think over and try to understand what will be the many side and what will be the one side when I have to define relationship between these tables. How do I define a relationship between these tables now? So I have fact table, which is my transactional table. On a daily basis, lot of transactions happen. Whenever people purchase items, new records will keep on getting inserted. Okay, this is my fact table. This is my fact table. And then with this are associated the dimension tables. With this, I will associate the dimension tables. So maybe the product table. Okay, and then the market or the location table. Maybe another table holding the names of the regional managers, anything of that sort. So given the product ID, product 1 could have been sold multiple times. Product 2 could have been sold multiple times. Product 3 could have been sold multiple times. Given the product ID, when from here I reference this, I will find a unique record for product 1 with its name and type. So this is the many side of the relationship indicated with a star. And this is the one side of the relationship. So given the product ID, I can retrieve a unique product name and fetch it. Given the area code, let's say area code 970, the transaction happened, and another area code, the transaction happened. So given the area code, I can reference this table and a unique a record will be identified, the state to which that area code belongs. So this is the one side of the relationship, and this is the many side of the relationship, because in that area code, multiple transactions could have happened. So this is one to many, and from this side, it is one here and many here. This is one here and many here. How to recognize the one side of the relationship and how to recognize the many side of the relationship, I hope that part is clear. Now, how do we do this thing in Tableau? Let's go ahead and see that. Here, I'll get connected to the normalized data of coffee chain where I have all the three tables separated out. So I'll take fact table and I need to relate it with the location table and I need to relate it with the product table. So when I drag and drop it here in the interface, Tableau automatically detects the relationships and it makes the relationships. By default, it will always use many-to-many cardinality. It will not try to figure out what is the one side and what is the many side. It will always use many-to-many, which is not such a good thing to do. So what we could do is click on the relationship, this noodle link, and then here we can see it established a relation between fact table and location based on area code. Right? Given the area code, using that area code as my reference, I can figure out what is the name of the state, etc. from here. So there has to definitely be a common field and a relationship is defined. So now it is based on area code. We could just go to performance options and change the cardinality. I know in fact table, area code comes up repetitively, but in the location table, it is unique. So we can make a many to one relationship over here. Now let's check product and fact. Here also the same thing. Tableau always uses many to many, which is not the right thing. You might have to go and tweak it. So fact table, we know that products are sold multiple times. Each product could appear multiple times. This is the many side. And what about product table? There is a unique record for every product in here. So this will become the one side of the relationship. Once the relationships are defined, we could just go ahead to the worksheet and create whatever chart we might want to create. So let's say I have area code. In different area codes, transactions have happened. I would like to check the total profit. Now I need to know which state it belongs to. I could simply include state here. Okay, I would like to know what is the market size. I could simply bring in market size here. Maybe I want to know, given the product ID, okay, let's take product ID also. that the people have purchased and their name. So name, I'll have to reference from here. Product 2 is Colombian, product 5 is Mocha, product 6 is Decaf Espresso, which I'm bringing from the other table. So this is how it works. The tables will remain independent. They will not be joined together and they will not be denormalized. The tables will remain independent. We need to know what is the many side and the one side of the relationship. And then when creating the chart, you could bring data from all the tables between which the relationship is already established and create your chart with that data. So I hope you all got some clarity on what is a relationship. If anything wasn't clear, or if you feel the concept can be improvised a little more, do let me know through your comments. And as always, thank you for your support. See you. Bye-bye.